All right, and let's get into cardiovascular system. Now, this is very, very important because without your heart doing its thing and without the arteries and veins being the transportation, yeah, you're dead. Okay. So this is a critical point to life. And the cardiovascular system is considered having four parts. The heart, the pericardium, which is the area around. Remember, peri means around. Cardium is the heart. Okay. And then, of course, the arteries and the veins. And the way I remember, I used to always get confused between arteries and veins is which ones are outgoing and which ones are incoming. So think of A for away, okay? The oxygenated blood leaves the heart via the arteries, going away from the heart and travels to every single cell and organ in the entire body, delivering these little oxygenated cells, and that's what cells eat, you know. So it's kind of like, oh, I just thought of this. It's kind of like the DoorDash of the body. Oh, that's so perfect. Only you don't have to call and order it. It's one of those like they do in Amazon, you know, where you have that continuous, it just continually delivers the oxygen to every cell in the body because that's what it needs to be nourished. Okay. And then you know what happens after you eat. So the veins come along and they are the waste collectors. Okay. The veins pick up all the garbage and the waste after the cells have eaten and been delighted on all that fresh oxygen. And then there's the, you know, after part. So the veins pick up the after part and head back to the heart where and then it goes to the lungs where the veins exchange the poopy, which you exhale, then you inhale oxygen and it goes right into the cells, which then travel into the heart, and we go through the whole thing all over again. Isn't that amazing? You know, I have been teaching this for a long time. I've kind of had my body for a long time, but I will tell you that every time I go through this, I am amazed at how phenomenal this system, the design of this system is incredible. Okay. So I thought because the arteries and the veins, we're going to focus today on the heart because, you know, okay. So your heart, which does not look like a Valentine, in case you didn't know, a Valentine heart is actually shaped like a woman's butt leaning over. Yeah, I know. Ugh, well, all right. This is what your heart looks like. And it does not come in blue and red. Blood is red everywhere in your body. The illustrations here and in your textbook, and don't think that I once had a student tell me that veins are blue and arteries are red because that's the colors in the book. Okay, that was a long time ago, but I just always like to confirm. Okay, in your body, blood is red regardless of the outside color or any other configurations. This is everywhere, every human, and actually maybe other species as well. Okay, so the heart beats, normal is about 60 beats per minute. Okay, we have tachycardia, Tachy, tachy, which is the prefix for fast. Oh my gosh. Oh my gosh. Oh my gosh. Oh my gosh. There's a bear in my driveway. Oh my gosh. Actually, that's what happened to me, but it was a snake at my front door and the neighborhood cats had it cornered. Oh my God. All right. All right. Now, if your heart is too slow, maybe you're like lying in a hammock and there's that nice, gentle sunshine with a beautiful breeze. Your heart rate might go down, and if it goes too low, that's called bradycardia. Okay, B-R-A-D-Y. Brady, prefix meaning slow. Okay. All right. So each beat is a compression. And if you put your hand on your heart and you focus a little, you can feel your heart beating. 1, 2, 3. That's your heart contracting to force blood through it and out through the arteries into the body. Okay? So how does it know to do that? This is part of your autonomic nervous system. And your nerves, there are nerves built in to the heart, all the way around the heart, into the muscle around the heart. So your autonomic nervous system says contract, release, contract, release, contract, release, contract, release. And that's what forces your blood through your heart to get oxygenated into the lungs, back into the heart, and on its way through the rest of the body. Okay, so you see, and this is another thing that I marvel at in the human body, is how all the pieces, parts, all the different body systems work together. And that is why sometimes it's difficult for a physician to diagnose a patient like that, because there are so many moving pieces. There are so many things that, that could affect this, cause this issue, these signs or symptoms. And that's why we have diagnostic testing, but that's a whole nother conversation. Okay, so the heart chambers. The heart has 4 sections, 2 on the top and 2 on the bottom. The top chambers are the atria. Atria is plural of atrium. So you have the right atrium and the left. Wait. This is my left hand. The left atrium and the right atrium. Remember, your directions are always the directions for the patient, not the physician or the healthcare provider. So this is my right hand. This is my left hand. So this is my right atria and my left atria. Okay. And this is the top half of the heart. They are not heavily walled, okay, but they fill up with the blood that's returning to the heart. So it could be returning from the rest of the body. It could be returning from the lungs, okay? And the blood is filled with the atrium is filled with blood, and it sits there just for a second. Okay. All right. And the septum is the wall in between the right and the left, is the cardiac septum. Okay. The top half of that is the atrial septum. Okay. Because, we have to have a division. Let's go back and take a look at the picture. Okay. So you see, here's the right atria, the right atria. This isn't a very good picture of that. Okay, I should have gotten a better picture. I'm sorry. All right, look in your textbook. There are good pictures in your textbook. Okay, so atria at the top. Again, A, first letter of the alphabet, that comes first, right? Okay. The bottom half of your heart are the ventricles. Right ventricle, left ventricle. Now, the blood passes when it's time. The atrium contracts and pushes the blood through a valve into the ventricle. It's really amazing. It's like little electric doors, okay? So the atrium is full, and now the door of the valve opens, and the blood goes into the ventricle, okay? Piece of cake. Now the doors of the valve close, and blood comes and fills the atrium again. Meanwhile, the heart beats, and the blood from the ventricle goes into the arteries on its way. Okay. And the part of the cardiac septum in between the two ventricles is called the ventricular septum. Okay. Makes sense, right? I hope. All right. Now the heart valves. You have these valves, one on the right side and one on the left side. In between each atrium and each ventricle. Okay. And you may have heard or may know somebody who's had a problem with their heart valves. You know what? I'll tell you, health science is incredible. They now can replace the valve, but wait a second, it's not open heart surgery. They enter via the femoral artery in your thigh, in the patient's thigh. And they thread a catheter all the way up into the heart, and the catheter is carrying a new valve. So they just take out the old valve and put the new valve in. Bing, bang, bong. It's just right. And you get a little Band-Aid on your thigh. Right. I had open heart surgery. Oh, wait, no, it wasn't open heart. It was closed heart through my leg into my heart. Amazing. Okay. So, like I said, the valves in between the atrium and the ventricle are there because we don't want blood going backwards. Okay. The atrium empties out, the door opens, the blood from the atrium goes down into the ventricle, and then the door closes because we don't want any splashback. That's really bad. Okay. So we have these chordae tendineae that connect the mitral, also known as the bicuspid valve, because heaven forbid we should only have one name for one thing, right? So, and this is kind of interesting. The mitral or the bicuspid has only two cuspids as part of the valve on the left side, but on the right side there are three. I don't know. Okay. And they're tethered. The valves are then tethered into position so they don't move around, which is good. Then you have a valve, the pulmonary valve, that controls the flow of blood from the heart, from the lungs, pulmonary lungs, and the aortic valve function is the same as double doors. Okay. So again, it's opening, let the blood flow, and then closing again. And you may hear of somebody who has a valve problem because the doors don't close all the way. Blood can then leak. That's not good. Okay. Also, if the valves close prematurely before all the blood is out of the atrium, that's a problem also, because if the blood is just sitting there too long, it can clot, and clots in the flow of things, not good. Why? Because it's kind of like being on the interstate and there's an accident. It stops the flow of traffic, doesn't it? That's what that is. Okay. And the pericardium, which is the muscle that encases the heart. And the pericardium has 3 layers to it. And this also is a a reminder of some of your prefixes. Okay, so we have cardium, right? We already established that's the heart. So we have endo, which is the prefix that means inside. Endocardium, the innermost layer of the connective tissue and the muscle, and it includes the Purkinje fibers. I love that word, just because it's just so very different. Okay. All right. Then you have the myocardium. We already have cardium as heart. Myo means middle. And this is thick like a muscle. And look, it's made of cardiac muscle tissue, myomuscle. Okay. Provide strength to power the contractions, right? Because remember, the autonomic nerve system is going to say contract, but you still need that power, right? Okay. And then the epicardium, outside and around, is the membrane that protects the heart. And, you know, it reduces friction. It's serous, which is it's lubricated in a fashion so that it lessens the friction as the heart moves within the muscle. Okay, you don't want that to rub. Okay. All right. So I thought that, you know, remember, piece by piece, inch by inch, that's the way to learn. You cannot engulf into a new language. And repetition is your secret weapon. Okay, so review things often. Most students, and everybody has their own way, and I respect that. Okay, most students find an hour a day is better than 3 solid hours, but you have to find what works for you, and I applaud that. Okay. All right. But review often. Flashcards are a great idea too. Make them yourself. Don't buy them, because the act of actually writing things out is what helps your brain learn. Okay. Use a medical dictionary. Seriously. And I like the little paper one. Okay. Because it can always be right by your hand. You don't have to click somewhere else. You don't have to worry about Wi-Fi and the strength, whatever. Okay, just pick up that dictionary, and that's what I want you to do. Just pick up that dictionary, look up that word. It literally takes seconds, but reading that word and that definition that's 100% accurate is going to embed it in your brain. Okay. And then whenever you're confused, whenever you're not sure, anything, I don't even know what to ask, please query, ask me. I'm the one. I'm your teacher, and I know stuff, and I have 5 medical dictionaries, so you know I'm going to tell you the right answer. All right, so you just email me and I can email you back. We can set up an appointment to talk on the phone. We can Zoom, we can one-on-one Zoom, we can FaceTime, we can do WhatsApp, whatever. I'm here to help you in whatever way is best for you. Okay, any questions? I'll take that as a no. Okay, all right. You all have an absolutely wonderful day and rest of the week, and keep learning.
Thank you.